Okay, so we are going to talk about special integration techniques. It is chapter 7 in your book, but chapter 7 is pretty much just for BC. So, but there are maybe 2 or 3 things that you need to know as AB. So I took those out and I created some worksheets, which is your homework tonight. So your homework is this 1 page, front and back. That is homework that's due tomorrow. So just 8 problems that's due tomorrow. Okay, these are special integration techniques that you have to know. First one is the video that you watched last night about inverse trig functions. So how to take integrals when you can recognize that there is an inverse trig function. There are only 2 that you really need to focus on, which is first one is the inverse sine, the second one is inverse tangent. So let's look at those again. The derivative of inverse sine. Okay, this time I'm going to put inverse sine x over a instead of just x. So we pretty much kind of memorize just x, but a lot of times you are not going to see things just in that form. There might be something else multiplied to it. So let's look at what it looks like if it were x over a. Okay, so first of all, what is the derivative of inverse sine in general? Do you remember? Probably not. It is 1 over, I believe it was 1 minus x squared. Right, that's the general form. But x in this case is not x. It's x over a, right? So then we can't do that. We have to do x over a squared. Now, because x is not x is x over a, we have a chain rule that we have to apply. So we have to multiply by 1 over 8. Okay, at this time, this is not the form that you will see in most books. You need to simplify this. So this is 1 over x squared over a squared times 1 over 8. Are you guys okay? Okay, so now we have a complex fraction here. So we don't want this complex fraction here. So what we want to do is combine it together. You guys seem a little not confident, so I'm a little bit worried. Are you guys all good? Okay, all right. So this is a squared minus x squared over a squared, and then there's still multiplied by 1 over 8, correct? Why does everything seem so like, Okay, all right. At this time, what we can do is you see that square root of, and then in the denominator is that a squared, right? So that a squared can come out of the radical. Okay, 1 over square root of a squared minus x squared over a, and then times 1 over 8. There's so many like, are you guys okay? Okay, all right, next. I'm going to flip that fraction. So a over a squared minus x squared times 1 over 8. Are you guys okay with why I flipped it? 1 divided by a fraction is 1 times the reciprocal. Okay, so the a's are going to cancel. 1 over square root of a squared minus x squared. So this is the form you need to memorize, that the derivative of inverse sine of x over a is blah. Now, the thing is, we are trying to integrate from a form. So the thing is, you need to recognize this. If you see this part, this 1 over square root a squared minus x squared, so a constant square minus x squared, you need to know that means inverse sine. So that's all you need to remember today. This means I need to think about inverse sine. All right? Okay, inverse tangent is similar, but let's not go through the whole integration process. I'm just going to give that to you. dx of inverse tangent of x over a is equal to a over a squared plus x squared. Okay, again, what I want you to recognize is a squared plus x squared in the denominator. When you see that kind of form, you need to think inverse tangent. Okay, so those are the two forms you need to recognize. One is you have a square root of a constant squared plus x squared. The other one is some number over x squared plus, a squared plus x squared. So when you see those two, you need to think, oh, inverse trig function. All right, so let's go ahead and review. So the other ones are not going to be tested, so we're not going to spend a lot of time on it. The other ones, if you're in BC, you have to know all 6 inverse trig functions, but for AB, just those 2 is sufficient. Okay, so find the integral of this. So what does this remind you of? Is this inverse sine or is this inverse tangent? Arctan, right? Arctangent. And this is a very simple arctangent, so this is just inverse tangent x plus c. Please make sure you have plus c. It's an indefinite integral. Okay, easy one because it is just in the very basic form. Now let's look at something that's harder. This one, 1 over 9 plus x squared dx. What function could it have come from? Inverse sine or inverse tangent? Inverse tangent, right? Okay, but that 9 is the problem, right? So here's what you do. Okay, let me do this on the side. Yeah, question? Okay, 1 over 9 plus x squared dx. So we know that it has to come from inverse tangent. It's just that we don't know what that number is. So let's do something where we have to do some kind of tricky things to this. Okay, so what we want to do is look at the denominator. We're going to factor out 9 because I want it to look like a 1. Right, so in the standard form of inverse tangent, it's 1 over 1 plus x squared. So I don't want that 9 there. I'm going to factor out the 9. Okay, so 1 plus x squared over 9. Okay, when you take 9 out, you're basically dividing every term by 9. Now take a look at this one. This one, the x squared over 9, or whatever that is going to be there, is always going to be something that you can square. So you're going to change it into something squared. Okay, and then at this time, it's much nicer if you, every time you have a constant or coefficient, take it out of the integral. So you don't look at it at the same time. So it's going to be 1 over 9. 1 over 1 plus. And then that x squared over 9, you always want to change it to something squared. So that's going to be an x over 3 squared dx. Okay, at this time, it pretty much looks like an inverse tangent form. Except that there's an x over 3, not an x, right? So what we want to do is u du. So u sub. So u is x over 3. du is going to be 1/3 dx. Okay, so recall u sub. We take the most complicated part of the integral and we make it into a u. Take the derivative of that on both sides, du and then dx. And we're going to substitute it back in. Now, in this integral, there is no 1/3. So what we want to do is multiply everything by 3 to get rid of that 1/3. So 3 du is equal to dx. Now we're going to substitute back in. X over 3 is u. So this x over 3 becomes u. dx becomes 3 du. So this dx becomes 3 du. Okay, so this is 1/9, 1 over 1 plus u squared, and then that dx becomes 3 du. So I'm going to change it a little bit and just put 3 here and then du. Are you guys okay up to this point? Kind of recall u sub a little bit? Okay, again, if I have a constant or a coefficient, I always take it out of the integral so I don't look at it anymore. So take the 3 out, the 3 and the 1/9 will cancel, so it's 1 over 3. 1 over 1 plus u squared du. All right, so now what is the integral of 1 over 1 plus u squared? Inverse tangent, great. So now we have gotten it to an inverse tangent form. So this is 1/3 inverse tangent u plus c. But do I want to leave it in u? No, I want to substitute x back. So this is going to be 1/3 inverse tangent x over 3 plus c. So this is the answer. Are you guys okay? Okay, so the whole idea is first, when you see the problem, you have to recognize, oh, this is going to be an inverse tangent problem. To make it into an inverse tangent form, we have to first get rid of that 9 because it should be 1 plus something squared. Okay, so get rid of that 9, and then eventually you're going to do some u sub. Yes?
Can we just times 1/3 and times 3?
Yes, there's a lot of other shortcuts. Yeah, so for this problem, yes, there's a lot of shortcuts. You can just do that. But this is kind of the general way of solving it. Okay, this one. So what form might this have come from? Inverse sine or inverse tangent? Sine, okay? So for sine to work, the number comes before the x squared. Something minus x squared. So you got to complete the square. All right, so the answer is inverse sine of x minus 1 plus c, and then once you evaluate, the answer is pi over 2.